And welcome to this video. Today I'm going to be going through some basics about amino acids and peptides. Now this is only a very light brush over. We're only looking at the chemistry of these and particularly how it's likely to relate to what you might see in an exam question. So first off, what is an amino acid? Well, amino acids are molecules that contain both a carboxylic acid group and an amine group. Now that's the basic definition, so you've got an amine and an acid, hence you have an amino acid. However, what most people talk about when they refer to amino acids are the naturally occurring essential amino acids which all living organisms use to create proteins and peptides. All of these naturally occurring amino acids, and I'll show you the structures of them in a moment, have the amine group on carbon 2. So there's a carboxylic acid group on carbon 1. On carbon 2 has an amine group, and then there is some other bit. These amino acids aren't usually named systematically. It's just they have common names that most people use. And pretty much all of them, other than glycine, form optical isomers or enantiomers. So let's have a quick look at some of these structures. First off, this table shows what we call the backbone structure. So the carbons are just the intersections and the endpoints of that zigzaggy line. But you can see that there are a huge range of possible structures. I want to show you about a few that are more common, or not more common, they're all common. I want to show you a few that are fairly simple structures. It is important to note, by the way, that of these amino acids, some of them are acidic, some of them are basic. There's all sorts of properties of them. Okay, so let's have a look at a couple. Here are some which you may come across in your exam. Alanine, glycine, serine, and valine have definitely all been in exams in the last 3 or 4 years. Okay, now the structures. If you see, they're almost always drawn with a straight chain across from the amine, carbon, and then carboxylic acid group, whichever way around they go. So it could be carboxylic acid, carbon, amine group. And then in the middle carbon, there's usually a hydrogen and some other group, which is usually called an R group. If you're given a question that doesn't have them drawn in this way, just redraw it that way because it makes it so much easier when it comes down to determining how to either link them together to form a peptide or how to break up a peptide to form an amino acid. Just a little piece of advice. Okay, so amino acids are typically solids at room temperature. Because of their structure, they have an amine group and an acid group. They form these internal salts. It's quite interesting. If you're curious to learn more about them, I suggest you look up what's called a Zwitter ion, but that's only for interest's sake. Like I said, they can be acidic, they can be basic, they can be neutral, and they link together to form peptides or proteins. So a smallish number of amino acids joined together is usually called a peptide, and a large number is called a protein. These are linked together through amide bonds. So you could think of a peptide as effectively a polyamide polymer. Okay, which is a bit interesting. All right, so what you end up with, they link together through condensation reactions in effect. So you can see on the diagram on the right hand side, you've got in this case 2 molecules of glycine, which is the simplest amino acid out there, and you take the OH off the carboxylic acid group and the H off the amine, join them together, and there you have your peptide. Now, you can link together obviously 2 of the same amino acid. More commonly, they tend to be different amino acids. And The number of amino acids and the order in which they join up determines the function of the peptide or protein. Now, typically, just a bit of nomenclature, I suppose. If you have 2 amino acids joined together, we usually call that a dipeptide. 3 is a tripeptide, etc. Once you get 4, 5, 10, we call it a polypeptide. And once you get over, now the numbers do vary. I've said 100 plus, that's amino acids, would be what I'd call a protein. Some textbooks will tell you 20. It does vary a wee bit. Okay, so joining them together, condensation reactions. Now you could join them, this particular diagram that I've got here shows glycine and glycine joining together. But if you had glycine and a different amino acid, say alanine or something like that, you could join them together in 2 different ways, because the carboxylic acid of one and the amine of the other is going to give you a different combination to if you flip them around. And that has come up before in exam questions. The other thing that very commonly comes up is about the hydrolysis of peptides. Now, peptides, remember, are basically just amides. Complicated looking amides, but still amides. So, as with any amide bond, you can hydrolyze it in either acidic or basic conditions. And if you're not familiar with hydrolysis, please go back and check out my hydrolysis video. So, when you hydrolyze a peptide, you get your original amino acids back. But, and this is the important thing, you have to do this in either acidic or basic conditions. So in acidic conditions, all of your basic amine groups get protonated. The carboxylic acid group stays the same. And in basic conditions, all of your acidic carboxylate groups get deprotonated. Now that sounds tricky. It's really not that complicated. Let me show you what I'm talking about. Okay, so here's a very simple dipeptide made from glycine and alanine, which are the 2 simplest amino acids that you can have. In a hydrolysis reaction, just like if I was hydrolyzing an amide, I'm going to split it between the carboxylate and nitrogen groups. I'm going to add H onto one side and OH onto the other, and so I'm back to my 2 original amino acids. However, in acidic conditions, where I have H plus present, what actually happens is instead of having NH2, I get NH3 plus, and that happens on both amino acids, not just on the one, but on both. That is really important. So many people only do one, and they seem to forget that there are actually 2 amine groups present, and so both of them get protonated. In basic conditions, we end up with something very similar happening, but instead of protonating the amine group, we are going to deprotonate the carboxylate group. So in basic conditions, you're just going to take away the H from the carboxylate group and put on a negative charge. Just there. Oops, that last one on the right hand side should be an O. It's just that I managed to rub a little bit off with my finger. Okay, so, and again, you have to do this with both molecules, not just the one. Okay, so key things with peptides: they hydrolyze and you can form your amino acids back again, but you've got to remember to protonate or deprotonate as appropriate. Okay, thanks for watching, and I'll see you again soon.